Okay, so there is a formula for experimental probability. Like, it's just the probability that an event is going to occur. If it's 0, that means it's not possible. Okay, the event is not possible. If it's 1 or 100, that means like it's 100% possible. So a lot of times in probability, you'll get a number between 0 and 1. You can change that to a percent, and it's like 0% to 100%. Let me see, I think I have a video we'll watch.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about how to do math with things that only sometimes happen. They might be likely or unlikely. We're going to learn about probability. Usually in math, we deal with things that always happen the same way. They're completely certain. Like if you add 1 and 1, you're always going to get 2. If you multiply 2 and 3, you're always going to get 6. There's no uncertainty at all. But in the real world, things aren't always so predictable. Take a coin toss, for example. We can't predict whether it'll be heads or tails. It's unpredictable or random. And that's why some people will flip a coin to help decide which of two things to do. That's how I make every decision in life. Why am I not surprised? Oh no. Good luck. But even though we don't know what each coin flip is going to be, we do know a few things about it. We know that with a fair coin toss, that heads is just as likely to show up as tails. The probability of an event, like getting heads or getting tails, is a value that tells us how likely that event is to happen. With our coin toss, since each side is just as likely, and there's only 2 sides to a coin, if we flipped a coin a lot of times, we should expect that about half the flips will be heads and about half the flips will be tails. That means that the probability of flipping heads is the fraction 1/2, and the probability of flipping tails is also 1/2. Let's look at this in a little more detail on something called a probability line. It's a number line that goes from 0 to 1. A probability of 0 means that an event cannot happen. It's impossible. And a probability of 1 means that an event is definitely going to happen. It's certain. That's why the probability line only goes from 0 to 1. An event can't be less likely than impossible, and it can't be more likely than certain. A probability of 1/2, like with our coin toss, means that an event is just as likely to happen as it is to not happen. A probability less than 1/2 means that an event is unlikely, and a probability greater than 1/2 means that an event is likely. Oh, and in addition to fractions, it's also common to write probabilities as decimals or percentages, since you can easily convert between those three. A probability of 0 is the same as a 0% chance of something happening. A probability of 1/2 is the same as a 50% chance of something happening. And a probability of 1 is the same as a 100% chance of something happening. Now that you know how a coin toss works, let's see an example of an event that is unlikely, using something a little more complicated than a coin. Let's take a look at dice. A standard die has 6 sides numbered 1 through 6. When you roll it, any of those sides is just as likely to come up as the others. That sounds a lot like flipping a coin, doesn't it? Each side of a die is just as likely to come up as the others, and each side of a coin was just as likely to come up as the other. So you might expect that the probability of rolling a 3 is 50%. But remember, with a coin toss, there are only 2 possibilities, heads or tails. With dice, there are 6 possibilities, and that's going to make a difference in its probability. One way to think about it is that it's certain that one of those 6 sides will land facing upwards.
Okay, I'm going to stop it here. I wonder if I am still recording. Okay, and look at some problems. So this, like what he's saying, okay, you have 6 sides, right, on dice? All right, so how many 3s are there? 1. There's only 1 3. So you have a 1 out of 6 chance of rolling a 3. Does everybody understand that? It's so, and if they write it as a decimal, so you just do 1 divided by 6, it would be 0.16 repeated. Okay, they might write it like that. Or if you write it as a percentage, it might be like 16.6%, because it just keeps going with the 6. Okay, do y'all understand that? So that's your percentage of your chance of getting a 3 on a standard die. This problem, it says there are 60 vehicles in the parking lot today. 15 are pickup trucks. What's the experimental probability that a vehicle is a pickup truck? So an experimental probability means like you're looking at something and you can, see, okay, there's 15 cars out of how many? 15 trucks out of how many? They said there's 60. So your probability would be 15 out of 60. You always put it over the total. Does everybody understand that? If I was to divide that, you could get it as a decimal, or what percent would that be? 25%. So 0.25 or 25% chance of there being trucks out there in the teacher's parking lot. Let's see what else. So when you gather data from an observation and you calculate the experimental probability, okay, you observe it and see. So let's look up here at, hold on, I'm going to make sure I'm resuming this. Okay, so number 3 and 4, they want us to do a little experiment. So to see for the true false, we're going to flip a coin, because we're going to say heads is what? Heads is true, and then what?
Tails is false.
Tails is false. And how many times do we have to do this? It says there's 4 questions.
20 times you said?
So, well, let's
40
see.
times,
What's the
okay.
probability of getting at least 3 correct answers on a 4-question quiz? So let's do this. Let's just do it 4 times and see what we get, just for now. Okay, ready? What'd you get?
Heads.
Heads. So let's
That's
see.
right.
All right, and then do it again. Yeah, we'll say heads, you got it right, and tails, you got it wrong. That's what I needed to say.
Tails.
You got it right. Tails, you got it wrong. So tails, you got it. So we're going to say right, and then you got it wrong. All right, what's your next one?
Tails.
Okay, so you got it wrong. And then do that again.
Heads.
Heads. Okay,
50-50. That's
so, but it says, did you get at least 3 correct answers? No. So on this one, we didn't, but that was one test. You would probably have to do that like 10 times. Do you want to flip that coin 40 times?
Sure. Yeah, let's
Okay,
do it.
we'll keep going. So on this one, no. All right, we're going to say that was, you only got 2 out of 4 right. Let's do another one. All right, what'd you get?
What?
Heads.
2 out of 4.
Yep, he only got 2 out of 4 right. Now he got heads, so he got it right. All right, let's see what else.
Heads.
Okay, got it right again. Then what?
Tails.
Wrong. Okay.
Wait, how is he getting?
It's tails.
If he gets
Tails. Yeah, we said if you get heads, you got it right. I put true at first. I didn't mean to do that.
okay.
Tails, he gets it wrong. So again, he only got 2 out of 4. So the first one we got 2 out of 4. The second one is 2 out of 4. Our goal is to get 3 out of 4. We got to do this 8 more times. You okay with that? Okay.
Heads.
Heads. Okay. I'll pause the video and then let them see.
Heads.
All right. So we did our experiment 10 times. He flipped this coin 40 times. So did he get 3 out of 4? At least 3 out of 4. Let's see. Right here, 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 and here. How many is that? 4 out of 10. So what's the chance of getting at least 3 out of 4 right? 40%. So this was an experiment. It's just experimental probability. Do y'all kind of see that that's what they were wanting us to do? Yeah, you can define any kind of experiment. I'll go back. Let me see. I think when we get to your study guide, I want to say that they generate their own thing, so we won't have to do it on the calculator, so I won't do any more of those. But you can always use your calculator. I'll just say how you do it. If you wanted to randomly generate numbers, you go to Math, to Probability, and it's number 5. And you just tell it to randomly generate some numbers, like if you have a 5-question multiple choice test, guess answers at random, what's the probability of getting at least 4 right? So you would just do 1, 5, or no, if you want at least 4 right, I think you would do 6 and then 10.
What do you do when it's like this?
Let me see what yours says,
Okay.
because that might help me know. Oh,
I just put it as 1, 6, and 10. I did 1.
yeah, just try that. 1, 6, and then it should give you 10. And what it should do is give you 10 numbers.
Here's your quarter.
Oh, it should be 1, 5, 10. That's what that means. 1, 5, 10. Because 5 is your answer choices. So let me go. It should look like this. 1, 5, 10. Huh? Oh, thank you.
Hey, that was a good
I couldn't even see it though. Okay, sorry, y'all. It's 1, 5, 10. On this, you have one right answer. There's 5 answer choices. Isn't that like it is on the ACT? A, B, C, D, or E. And then you're going to have 10 numbers. Okay? So, yeah. Okay. Anyway, and that would just spit out answers. That's how you would do that. I think on your study guide and on your test, it's going to print out, and that's what you would see. Basically like this. Let me just show you this problem, and we won't do that one on your test. On your study guide and your test, they're going to say, hey, here's a bunch of numbers. All the ones represent the number you got right. So how many were right on this one? 5 out of 10. That's only a 50%. They didn't pass. How many did they get right on this one? Only 1 out of 10. They didn't pass. How many did they get right on this test? 5 out of 10. They didn't pass. Right? They did all these numbers, but hey, when they got their calculator or computer, just gave them some numbers, the ones represent how many they got right. Hey, on this one, they got 6 out of 10. They passed. They did this 20 times though. So only 1 out of 20 passed. That was why that in that experiment, it was 1 out of 20. Again, we'll do that on that study guide day. Okay, theoretical probability. This is like, using a theory, okay? This is where we get to the number cube or die or whatever. I'll do this. So it says, what's the probability that you're going to get a 5 on a standard number cube? That just means like dice, okay? What's the probability of getting a 5? How many 5s are on there? Out of how many numbers are on there? 6. There's 6, 1 through 6. That is theoretical probability, okay? Then it says, what's the probability of, let me find another one like that before I go to this one. Okay, like what we did up there on our spinner. What's the probability of getting a purple? Oh, the dark purple, I mean.
There's 2 out of 14.
2 out of 14. They can't see it on here. But, and then you could also divide, what's 2 divided by 14? I forgot what we said earlier. It's like 14% or 14.2% or something like that. Okay? Anyway, that's theoretical probability. Another one, it says, what's the probability that you're going to get a sum of 5 on one roll of 2 standard number cubes? So, y'all, if you have 2 cubes and you roll them, are y'all listening? Yeah. What's the probability that you're going to get a sum of 5? What all numbers would add up to 5 if you roll?
2 and 3.
Okay, 2 and 3, and then what else? 1 and 4. 4 and 1, right? 2 different cubes. So this one could have a 4 and this one could have a 1. What else? A 3 and a 2? Let's see. Anything else that can get, no, nothing else can add to 5. So we know there's 4 possible. Now, what's the total that out of how many different possible sums are there? Does anybody know how to find that? It's like your sample space on adding up all those. Anybody?
What did you say?
So I know that my chances are 4, but out of what? How many times or like how many different possible numbers are there to add up to? Well, there's 6 plus 6 and 6 plus 5 and 5 plus 6 and 6 plus 4 and 4 plus 6. Anyway, if you add them all up, it ends up being 36. I'll just tell you that. They said, okay, each cube has 6 numbers on it, so there's a total of 6 times 6. Remember the fundamental counting principle? Yes? 6 times 6? You just multiply them. What's 6 times 6? 36. What if they only have 5 numbers on them? What would they be? 5 times 5, which is what? 25. What does 4 out of 36 reduce to? You could reduce it to 1/9 or a decimal. Are we kind of getting this? Yes, no? Let's see. I won't do the combinatorics just yet. Let's see your paper. We will get to that in a second. Okay, so looking at 14 through 17 on your sheet, I'm going to do one like those. I have a guy, he's up to bat, and the strike zone depends on the height and stance of the batter. What's the probability that a baseball thrown at random within the batter's strike zone will be a high inside strike, one of the hardest pitches to hit? So do you see where they have the high inside strike zone, right? And what is that area? What's 4 by 6? What's 4 times 6? 24. So there's 24 inches, 24 square inches, right there. Out of, what's the total of our area? 17 times 22. Okay, what's 17 times 22? For the strike zone, 17 times 22. What's that area?
37.
Okay, so then I would just I would divide. I would put, what you're going to do is you're going to put 24 divided by that. What'd you say, 374?
Yes, ma'am.
And then that's your answer. Does that make sense, y'all? Like, what are the chances that you're going to have it in this zone out of this whole strike zone area?
That's all you do?
Yeah, that's all you're doing. So yeah, that's all it is. So on your problems like 14 through 17, you'll kind of have to know these areas because you'll have a circle, you have a rectangle, and you have a little triangle, right? So you'll have to know those areas. So it says you have this yard, has a circular pool and a triangular garden. A ball from an adjacent golf course lands at a random point within the yard. What's the probability that it lands in the pool? So what is the area of this pool over the whole area of the yard? Well, first of all, what's the whole area of the yard? Can somebody tell me that? It's just 50 times 100, length times width. What is 50 times 100? 5,000. Yeah, so on this one, it's over 5,000. That's the whole yard. All right, this one also is out of 5,000. I think all these are out of 5,000, right? Does everybody understand that that's our total area? Now you're going to have to find the area of those little things. The area of the pool. Do y'all remember how to find the area? It's pi r squared. Pi r squared.
Is this the pool?
The circle is the pool, yeah. So this one's going to be pi r squared. The area of a triangle is 1/2 base times height. Okay? So you're just kind of finding what those areas are and putting it over 5,000.
Where?
How do you what? Find the area of a circle?
You said pi or square. Do you type that in here?
Well, no, I would just do 144 times pi, whatever that number is.
144.
What's 12 squared? Does that make sense? Pi button, you might have to press the second. Let me see. It's 3.14, but where's pi? Oh, it's right here. Here's the little pi button. It's on that little up arrow. You have to press the yellow. Okay. So like on mine, I would do, 12 squared, it was 144 times pi divided by 5,000. Okay, so that is what percent chance, y'all? 0.09, which is 9%. Okay, which is what I would get. So I would end up putting, what's the theoretical probability? 9%. Or you could put 0.09. Okay, is that making sense? Yes, no? Y'all have to find those.
What do we put over 5,000? The 4.52?
Yeah, 452 point 38. That was what you put over that 5,000. Does that make sense?
Yes, ma'am.
Okay.
Okay.
So on number 22, I know I'm skipping around. We'll come back to some of the other stuff. It says the spinner at the right has 4 equal sections. Suppose you spin the spinner 2 times. All right? They were asking about, the first thing is your sample space. That means, like, what are all the outcomes? If I spin the spinner 2 times, could it land on a 1 and then a 1? Yeah. Could it land on a 1 and then a 2? Then a 1 and then a 3? Then what would be next? A 1 and then a 4? Okay, and then we'll change it. Thank you. Then it could also be, what else? Somebody tell me. A 2 and a 1? A 2 and a 2? A 2, 3? A 2, 4? Then what? A 3, 1? Are we kind of seeing this? Yeah?
Do we have to write all of them?
This would be your sample space if it asks. Yeah, go ahead and write all of it down. And then I'm going to write my 4s. Then my 4s. I could have a 4, 1, a 4, 2, a 4, 3, and a 4, 4. How many outcomes are there? It's 16. Remember, I have 4 possible things, right? And I do that twice. What's 4 times 4? 16. Remember, that's that fundamental counting principle. So you just multiply those 2 numbers. So I should have known already that there were going to be 16, or I could have counted these. But that's your total outcome. So there's my sample space. Then part B said how many outcomes are there, and we would say 16.
You wouldn't do the. I don't know.
It's crazy they expect you to write all this right here.
Where do we put 16 at?
On part B, I just put it on the left side of B.
No, C.
But without writing that, I hope you could figure out that there were going to be 16. Because you have 4 possible numbers, and I only did it, I spun it twice. So what's 4 times 4? 16. What if I had spun it 3 times? 4 times 4 times 4. Are y'all see that? Okay, that's what it's asking. Now, then part C says, what's the probability of getting a sum of 4? If I was to go by this, so I'm going to look through here. There's a sum of 4. There's a sum of 4. There's a sum of 4. So what's my probability? 3 out of 16.
Which would be?
Yeah, so you can leave it 3 out of 16 because that can't be reduced. You can get a decimal, or you could get a percentage. I'm good with any of it.
18%?
You said 0.18, so it'd be 18%.
There's
Okay.
0.975,
Yeah, or so you could round it up to 19%. So looking at 23, it says if x is a real number and it is 0, what are the chances that 1 over 0 is undefined? We're saying it is 0. All right, we know for sure it's 0. What's the chances that that's undefined? Is 1 over 0 undefined?
Yes.
Yes, so 100% chance. But remember, they would probably write a 1, because probability, a lot of times they use numbers 0 to 1. Or I would write 100% chance that that's going to be undefined, because I know x is 0. Okay? If x is a real number and it's not 0, it's not. We absolutely for sure know it's not 0. So what's the probability that it's undefined? 0. Very good. It's a 0. It's not going to be undefined because we know 0 is not in the denominator. That's kind of trick questions. Y'all can do 25. There was something I haven't taught you yet. I'm trying to find it. I'm guessing maybe it's 18 through. Let me see. We did all that.
104 out of 195, is that right?
Oh, let me see.